Okay, great. It's so nice to see you, especially because I see some familiar faces. I know some of you already, and I actually had some time today to meet some of you, so it's really great to have the same people, familiar faces. Great. My name is Karol Kowalczyk, and I'm pipeline technical artist, while Oskar is lead of procedural team. And the funniest thing is that no one knows what we do. And there are probably some technical artists here. Can you raise your hands? Do you know what you do? Like what your friends or your left or right side do? Because you usually don't. Each of us have...
And how many of you did something in 3D, be it Blender or whatever? Okay, awesome.
Great. So when it comes to technical artists, some of them make some plugins for Maya, maybe Substance. Some of them work with Houdini, and some are called pipeline guys who work with Perforce or Git or anything. And it's hard to categorize them. It's way easier to show how the game would like without our work than to describe it. So we'll quickly jump through the first slide, which should be about us. Let's go to the next one, and that's it.
Could slip. Lights out for a minute.
Could we have it a bit louder?
A little discomfort at first. Blurred vision, low contrast, glitches. Well, how's it look? Feel all right to you?
Oh, this is fantastic, Vic.
Stanley here with you, and we got another day ahead of us in this city of dreams. Ooh, I love this town. Love it like you might love a mother who popped you out on the steps of an orphanage once and now stops you to ask if you got a
I think we
smoke
have
for
some
her.
guessing, because
Every new day here means 100 new
it shouldn't be playing like that, to be honest. The thing is, sound is so desynchronized, so please just wait till it ends. So you probably already started wondering, is it about some texturing or maybe materials or maybe both? And while Oskar asked you, how many of you are 3D artists? I already realized that some of you are probably very familiar with textures and materials, but some of you just may not. So we... Oh, okay. The mic is on. Can we have it a bit louder, please? Okay, we're doing our best.
So let's wait a second.
Okay, is it better now?
Should be much better.
Great. Okay, these are just the first few slides, so I think you didn't miss the most important part. Anyway, to move back a bit, I noticed that not every one of you is a 3D artist. I guess you are kind of familiar with what UV is, how texture works, how to work with materials, but we made our presentation in a way that everyone can follow, and we'll be talking about our custom texturing system, about the whole pipeline, which is tools, the way it works, and how it's combined with the engine. But it's all built on some ancient technology from past decades of games, like 30 years to be honest. When we think about UV maps, that's the beginning of the 90s. So Oskar,
So what started this around 30 years ago is actually UV mapping, the most important thing. And you may be surprised because now we have powerful shaders, we can calculate whatever we want programmatically on the GPU, but UVs are still very important and they are still very efficient. So what UV mapping is, for those of you who didn't do 3D, it's basically taking a 3D mesh and unwrapping it to fit into a 2D plane. So then we can put an image on it, right? So here's the classic example, a cube being unwrapped. And here you see Quake 1. It's actually the remaster, but it doesn't matter, the content is exactly the same. So look what happens here. We have this environment and these soldiers. Everything, all the lighting, all the detail is painted on the texture. So there is no material, there is no lighting response, there is just a single color that has to contain it all. So the soldier has its, like you can see here, has its every detail, shadow, a little specular. Of course, the specular is independent of the actual lighting, right? It's baked into the texture, hand-painted even then. The only lighting we have is this, you know, multiplication of the color by some very rough lighting in the environment. And that's how games were made throughout the whole PS1 era, most of the PS2 era. Here I have another example. So look at this little imp. The lighting is off, right? Because the direction doesn't matter. It's just sticking there. And then we have a much newer game. It's Metro 2033. But the principles until that point haven't changed that much from 1994. We still have textures, most of them painted in Photoshop, now from photos, but still not scanned materials, right? And we have some additional maps, like specular map, telling us which parts are shiny and which are rough. But it's still not physical in any way. So let me show you the diffuse. It looks like that. So we have a kind of modern game, looking good, but the textures are still done the old school way. Scratches are painted in. There's just one color plus some specular reaction. This was already very sharp, so it's not a problem with quality in that game. The quality was sharp, just the workflow slowed down to such a point that you couldn't do a full open world game with it, because it's just it would just take too much time. So now, Karol, show the UVs.
Yep, we already told you that we improve the system. We have something custom, which we'll discuss later. But we take from what was made in the last generation, and we still have UV maps, and we still have some textures like diffuse and so on. Maybe it's not called diffuse, it's albedo, it's a bit different, but it's the same, and that's how the UV map in our game looks like. It's a bit more dense, but it's the same. Can I have the pointer, please? Mm-hmm. So, when we started going back to the roots journey, let's move to tools, how it was done by developers, not what players could see. We can start with UV overpaint. I guess some of you are familiar with that, and you may be still doing the thing. You open Blender or Maya or anything, you export UV map, you open it in Photoshop, maybe GIMP, Krita or anything, and then you paint over it. And then you have no live preview, in most cases. You also have no upscaling. If you start with some 2K texture, you can try to upscale it to 4K, but it's not gonna be the same thing as making it as 4K from the beginning. You also have no PBR, which means that you don't have physically correct values, and when it comes to talking about PBR, it's talking about few different textures, like normal map, roughness, or whatever you want to have. If I have any screw that I want to paint on my UV layout in Photoshop, I have to align everything. Everything. I do it, I have color in the right place, I run the game, and there is no displacement, because there is no bump map or no normal map. You have to keep that in mind. You have to keep those aligned, and that's tedious, and you have to fix stuff or just be fine with having some small issues, right? We don't want to have that. So we're gonna slowly show you how we do it our way. But it's not what was made in the first place. In the first place, we wanted to have some 3D preview, and some people were cheating. They were using old Photoshop with that 3D view. And yeah, they were able to texture that way, and I guess most of you didn't know this trick. I actually was looking for old videos, and my search filter had the last date set to 2010, just to avoid anything new. And yeah, you also see the title, there's some old NVIDIA Quadro. And then some company called Quixel realized that it's a good way to work. So they wanted to combine their knowledge about making 3D previews. And yeah, they made some nice 3D preview, but directly in Photoshop, which can actually work with PBR. Maybe it didn't at the beginning, but they started with painting with materials. You know, you were able to paint albedo and normal map and roughness at the same time, and that's very close to having PBR. PBR is, I could say that it's just about having the right values in that case. You have full-fledged editor, everything works fluently, and in a few seconds we should see a finished texture on our screens.
Yeah, so
maybe it's gonna freeze.
Quixel started a little revolution here, because while this was still Photoshop based, it made people think, okay, so we want to use materials now.
Yep. So, live preview, materials, great, but also, remember, alignment, that's great. And PBR is possible, but it's not perfect. We can do better. We could try painting over the actual mesh. It's so simple, right? Why export anything to any other program if you can make it in one place? Okay, and what now? Are there any issues? Because I think they are. We are resolution bound. You start with 2K texture and you end up with 2K texture. That's bad. We want to make maybe some next generation title next time, and we want to be able to upscale everything quite quickly. Maybe we'll have some decision choices during the development and we will bump the resolution. So that's a big issue. And yet again, we're back to painting all those textures separately, normal maps and so on. And these are also not perfect tools. However, we could try to work around it.
Yeah, so here you can see that we still utilize the painted masks, but this time we don't paint the final color. We paint the grayscale masks, and then we can attach what this mask actually means to the shader. So to the more complex material. In case of Blender, it's node-based, but it doesn't have to be. So basically, we treat the mask in a utilitarian way instead of painting the direct color in the end. So now we can just make a node that says, for example, the white area, meaning, you know, for computer, black is 0, white is 1, something in between is a gradient. So here, we just assign this reddish metallic material to the given mask. If we paint more such masks, we already can have materials painted directly in the 3D viewport, right? And this may sound similar to what you know from Substance, but the cool thing is we still retain the separate masks. So we can do, for example, tiling in material in real time. Let me jump further, right color? Yep. Okay, so what could be proper tools for such a technique? We can't use Blender because in Blender we won't have the engine parity by default. We can work on that. but maybe we combine something that artists prefer typically to paint and retain the capabilities. So
we have Substance Painter, already mentioned by Oskar, but we also have Mari. And some of you may be wondering which one is better and why choose a specific one. But it's a question which tool to use. These are just tools like hammers, and it doesn't really matter. They both have similar capabilities. And I personally believe that they are both great. You can use any of them, and if you are able to code for it, just pick the one you prefer. But Mari is known for super high resolution textures, which are not really, I think, in games, because we have memory limits and we want to have decent performance, and it has to run on consoles. So that's nothing special for us. We may not use this feature. And there is also Substance. But Substance is way easier to use. That's a great thing. That's really important. You can take people and teach them your system in just a few days, and that's a game changer. And what's more, Substance is more popular in games, so most of our artists already knew the thing. So that's what we stick to. And if you don't know Substance, that's just the demo. It's a full-fledged tool for making the thing we showed in Blender, but in actually professional way. There is no hacking your way through with some nodes. You simply paint mask, you select material, you tweak it, you have some generators for making maybe some worn edges, and everything is working. And that's all we needed. And you can make plugins. Oh, and as you can see on the screen, they also have pretty nice library for those of you that don't want to create materials themselves. Okay, I think I'm gonna skip the rest of the video and let's talk about limitations. Are there any? You already heard about one. It's performance. Yay, the thing we hate. And did any one of you struggle with optimizing your game? Don't be shy. Okay, you know the rumors. But there are some reasons, and we have to explain it. Each time a typical user uses Substance, he has to bake textures. So he's working with those great masks, and he doesn't really care about resolution. You can have any resolution you want in the material because there is tiling and it looks nice. And even though the mask isn't perfectly sharp, there is some little blend, or maybe you can adjust UV layout so it's not really visible. And then you bake it and you get a 4K texture. And it may look good in the preview, but then it looks like that.
Despite the high resolution, right? Because there's always some limit. There's always some blurriness. Yeah, so we already had the solution in Blender, right? We had the solution in Substance. Why don't we just use one of those and, let's say, deal with the limitations? So the point is, we really like painting masks, because painting masks is simple. You just paint whatever you want. You have the library of materials somewhere. Why would I recreate this if, I have a full set of environment piece? I want all of them to be in the same style and just apply the material. So we want to use predefined materials. We want to assign them easily to mask, just drag and drop. And in actual production, this proved to be super fast. Like people who are not expert in texturing or sourcing textures from photos or something, they can still be of amazing help during production. But we're limited by mask resolution, right? But thanks to that, if we keep the materials tiled, if they are applied in the engine itself, we are not limited by the baking resolution that vanilla Substance would give us. So I will show you step by step and pay attention of what's there, because here we start in Maya, but on the right here you see our custom software that we actually built it in Qt, in PySite. So Python plus the Qt library. There is a list of materials, a full collection, done by expert material artists in our company. Then people just pick what they want, on which layer they want. So like Substance, right? And they can configure this material per layer. The thing is, what's exported out of the software is only masks, grayscale masks, and then a very lightweight text file which describes what is on which layer. That's it. We have some limitations, but we still plug the system back to Substance. So we replaced the rendering of Substance by our custom shader written in GLSL that replicates the engine shader, like one by one, one to one. The only thing we kept, of course, is painting, because Substance is amazing in that. So don't replace the tool that's good. Don't try to create your own program if you don't need to. Just plug it into Substance. It has a quite decent API for that. And here you can see we paint, and something more happens. It's not just the revealing of the material. Actually, the mask itself here is very low resolution. It's like 128 pixels or 256, but we still get the super sharp detail. And that is independent of the zoom level you're in. That's because it's our shader that draws this material, exactly like in the engine, it's the same tag, instead of letting Substance bake it into some flat texture. So we retain the sharpness. The sharpness is defined by extra transition texture we call it microblend. In Unreal you would call it height rep. And see here, we have a list of predefined list of layers, up to 20, but the less you use, the more optimal the output will be. Here we choose one of these transition textures, and here you go. The same mask, different result. So the cool thing about that system is that you can paint very broad strokes. You don't even have to be precise, because the transition texture will do half of the job for you. And then, as you can see, everything is adjustable, so it means it's non-destructive. We can return to this paint job anytime we want, even at the very end of the production. And just one click, export it back to the engine. Nothing has to be redone. Nothing is lost. This is another thing that we did, because typically if you do layering, you have problems on the edges. They are flat, right? Because just two layers. So we added a special normal map to the transition texture, not visible here, but here you can see it's a normal map. So the texture also adds bumpiness to all this. It adds actual normal map just on the edges of the transition. So that's a bit of math, but it's not that complicated. You just have to find, let's say, the middle of the transition and only apply the normal map there. Don't apply it to places where it's fully 1 or fully 0. And thanks to this, you already get very decent results from like 5 layers. So base concrete, then some rebar, then plaster on top, then paint on top. That's it. And the configurability means we have just 350 materials for the entire game, for entire Cyberpunk. And 80% of all assets is textured with this. So small collection becomes very efficient because we make them tintable and adjustable in the tool itself. And I don't know if it's visible here, maybe it's a detail, but here we don't pick between roughness bias, so we don't shift roughness, we pick between roughness levels, meaning we contrast them or make them flatter. So it's full levels like in Photoshop instead of just simple bias. And this thing here is the same thing visible in the engine. So parity is like 95%. The lighting model is different because it's Substance, but you know. The artist can see exactly the same thing in Painter, in engine. If you use the same HDRs and the same color mapping lookup tables, you'll be able to be very proficient at knowing what you'll see in game, which is super important. We didn't want any step that requires, for example, baking on the render farm or something like that, because that detaches artist from the world. And here, the artist can just see their result in the game, almost instantly. So it makes the world more coherent, right? Here is another example. Look at this. Out of the same set of masks, just replacing the text files, which are super cheap, we got the whole crowd variation. We got 20 variants of the same jacket, almost for free in terms of memory size, because the materials are loaded anyway, colors are just numbers, and we just replace the file that describes what is on which layer.
I think we're a bit blessed by the knowledge, Oskar. We're talking about some text files and so on. What we mean is that we have a single file that has all the masks exported. And as you probably know, you need to make some manual tweaks and export stuff multiple times when using typical pipeline. So we decided to have a separate file format which describes all those layers. So then you can load a single already created multi-layer mask file, and then you can make more tweaks and save another multi-layer setup file, which can be created in a few minutes if you are really quick. But of course, if you want to have, some more expression, you can keep tweaking for hours. And that's how we can make multiple versions of each asset, which is very important because, for instance, city has some color coding. If you are, for instance, in Kabuki, you may notice that those buildings are mainly green or bluish. I'm not sure how to call this color. And if you go to Chinatown, a color totally changes. However, the meshes itself are often reused. So we have color coding there on the material setup files. And of course, we have a lot of citizens and crowds in the street. So we have to have a lot of garment variants. As you can see, the single jacket has more than 10 of them, and we have more pieces of clothing, of course. And is it perfect? And it's not. This question is there for a reason, but these are not reasons that would stop us from using the system. Could we have the next slide? The first thing you probably noticed is the left side of the UI in the tool. There is a list of materials, and list of something to pick from always means that there is a limited number of those materials. Of course, you can make more of them, but you have to use a separate editor. There is separate artist that tweaks them. And if you have some vision of something to use right now in this moment, you cannot do it. However, there is also a good side of this thing, which means that we have visual parity everywhere. Artists are using the same materials in the whole game, and if we update the material, the whole game is updated. What is more, we have 20 layers max. In Photoshop, you may use how many layers you wish. Here, you have to stick to 20. However, in most cases, 10 is enough. 20 may be used if you want to have, different details on your clothes or different colors of dirt, like, brown, yellow dirt, and maybe some blood. That's already 3 layers, and you have to have clothing, of course. So clothing may be 10. That's already 13. 20 seems to be enough for us. Then, when it comes to layers, we have to be honest that we have only a single blending mode. In Photoshop, you are used to having blending modes like screen, like darken, and you can create cool effects. Here, you cannot. You have only transparency. However, it's important for us to not have more of them because the simpler the shader, the better the performance. We also cannot use custom texture. What does it mean? If I have a jacket with some custom patch, that is custom image. Each color of it would have to be a separate mask in a multi-layer, which makes no sense. So we hack our way around of it, and we simply have a separate mesh, which has a separate material, and that's it. We don't need anything else. And the last issue is that it's not suitable for photogrammetry. You cannot just scan some rock with this tag and get material from it. but we have live preview, and resolution is not an issue. Oskar told you, we have masks which have 128 pixels, but it somehow still looks sharp because we have those microblends, those little textures used for materials which are loaded all the time because they are used by all materials in the game and there is no reason to unload them. And we have great parity, we have PBR, we have painting with that material, which is one of the first things that we mentioned that we lack from overpainting. And we can create a lot of variants. It's easy to learn. That's all we need. Summary, Oskar.
I also wanted to mention it's optimized in a way that typically, the more shaders you have and the more separate materials you have, you can have some problems with rendering the scene, right? There are maybe more technical terms, but draw calls, batching. But we had one material for the entire game. So first, it was easier to render if you use appropriate techniques. We utilized DirectX 12 for that. The second, there is huge incentive to improve the single material, because if you do, you improve 80% of the game. And the same about content. If you have some cool-looking concrete texture used everywhere, polishing it polishes the entire game. So yeah, to summarize, I would like to ask you if you ever work on tech, or if you ever request tech from programmers, adjust it to your needs. Like, think about the intuition in your team, think about the muscle memory people have, for example, when dealing with substance, or show them, would you like to paint on the mesh like that? Do a prototype? If they react positively, it means it's probably a good direction to try, despite some technical issues on the way. If a good solution already exists, just take how much you can from it. Don't try to reinvent the UI, don't reinvent the brush, focus on the things that you can add. And then, suddenly, you create a more powerful system than you even thought it's possible in the original software. Try to keep the workflow non-destructible. What does it mean? It means that if you can make something tweakable last minute, do it. Because otherwise, if, for example, you flatten your textures and you bake something in the end, you have to return all the steps to the back to change anything. You change the UV layout, you have to redraw textures, right? And half measures like substance trying to move the islands, it's not good enough. If you can have such a system, that basically you don't care about that. And as you probably saw, we also have the color swatches. The artists pick the color of the material. So these swatches were also like globally referenced. So if you want to tweak the red in the entire game, you just do it there. And basically treat the visual feedback as the priority. So don't let artists wait for some export. Don't let them wait for, I don't know, level designers to place stuff in the Word to test. Make it, the loop, make it as short as possible. Because then they have the incentive to improve, to try, to experiment.
I mean, you want artists to make something interesting. You want them to express themselves. So why would you give them tools that they hate to use? It makes no sense. If you are drawing, you probably, you like the tool, you like the pencil. And then you sometimes try to make the tool and it doesn't work because you have no visual parity. You paint the texture and you have no idea how it's going to look later. If you go to some Blender marketplaces, you will find some shaders that imitate shader from Substance because people were using Substance, exporting, and they had different results. That's just annoying. They have to see what they are getting because otherwise they are not going to stick with it. They are going to spend the least amount of time on the asset and then they are just going to move on because they don't want to work on it. But if they enjoy the process, if it's simple, and if they don't have to spend hours on learning it, you can leave them alone. They will make great stuff. So, let's bring it back to the game. But oh no, the video is stuck. Can you play it for us? Thank you.
Premium plan will cover 90% of the projected costs of your rescue and treatment.
TT-133 to control. Patient NC570442 secured. Stimulants being administered. 70 milligrams dopamine, 110 norepinephrine, 800 fibrinogen.
What we did is not the first approach to making such a material system. And we were quite lucky because there is a lot of sources online from other companies who tried to make the same thing. And if you are interested in those, you can take a picture of this QR code. However, if you are using just your inbuilt application scanner or something, it may not work because those expect simple link, and here's quite a lot of text, and they think that it's corrupted. So it's better if you just take a picture and then try it in any application. And it would be actually very, very nice to later find out that maybe some of you were working actually on one of those referenced links. Yep, and there is also one more thing, because Night City creation was a pretty long and tough and big project, and we appreciate all helpful hands, and one of those was the Sectoral Programme GAMEINN, because the project was co-funded by them, and the program was provided by the National Center for Research and Development. That's it, and we have some time for your questions. Hopefully we will be able to answer them.
Yep, you actually have plenty of time. So if anyone of you has questions. Okay.
Hello? With your system of materials, you said you have some preset materials that someone else made, and then your artists use them. How do you deal with the situation where a material changes later on, and then the model is not as the artist wanted it because something changed, maybe in the shader, maybe in the material, maybe in the way it's blended, the way the sliders work, or anything like that? Because you said make your workflow non-destructive, but then you have this problem of things don't look as they were initially created, and they might look worse. Do you have this problem, and how do you deal with it?
Okay, so the question was, if we have a common library of materials, but artists already paint meshes with them, and then somebody alters this material in a way that doesn't fit these meshes anymore, what do we do then? So yeah, that's an actual risk. So basically materials should be created early in some prototype phase, and then tried on meshes. If people like it. If they say the tiling is good, that's how it should look, then you should keep to the main features of that material. So if there is some, for example, pattern or rebars in the concrete, they should stay like it is. You should be very careful. What you can tweak is the actual look, the lighting response, the little detail. So yeah, most of our materials were frozen, I think, like 2 years before finishing the game. They were already there and only improved. If someone really needs a change, they should add a clone of that material and modify it then. Also, we have a very good art QA, which are not just testers, but they're actual, quality assurance, working with artists, knowing the tools, and checking periodically by themselves. So they are aware of issues if, for example, some significant change the roughness of something in the whole game. So that happened. Another thing, I think even more important, is not to delete resources that are in use, or not to change the color. So in the tool that I shown, but in a different variant, a material manager for people doing the materials, we had something that first scanned the game depot and checked which colors and which materials are in use. So if you tried to delete a color from the swatches or modify it, it told you, are you sure? It's in use by 1,500 assets. So yeah, you have to kind of guard yourself around that.
There's one more.
Hi, thank you for your speech. I'm Mikhailo Kachmala, technical artist, CI Games. 2 questions. How do you handle with streaming? Because you mentioned that over 300 materials. What's the native resolution for each separate ID? And the second question is how you handle with the order of blending. Thank you.
I think streaming is the easiest. We have 3 questions, in fact. The first one is how do we deal with streaming? And the second one is what is the native resolution we have in the materials?
Of materials and of masks, right?
Yeah, and the third question was, sorry, could you repeat? Order of blending. Okay, the third one also should be pretty simple. So when it comes to streaming, those materials are common. So if you ride with your car, and if you try to load them and unload them, you would have issue of them loading and unloading all the time. Like you enter a new district and someone has a jacket with leather that wasn't used 100 meters ago, it loads. Then you move by another 100 meters, it unloads. And it would be pretty performant offender, because we would have a lot of I/O and that's too much. So we keep it all in the memory, and we're strict about the limits, and they are very important, and that's it. When you load asset, it has masks and so on, but the material textures, the ones that are tiled, these are things that is always loaded. I think Oskar will know what the resolution is.
Yeah, so we're streaming only the mask themselves. And then the mask use a special compression that first cuts out the black area, if it can, and reorganizes the texture internally. And second, about the resolution, I think most assets were between 128 pixels square to 512, and only characters and very special machines or cinematic close-up have more. There is, I think, only a few of 4K textures. Because remember that each mask also is like, another layer, right? So like another grayscale texture. But as I said, in practice it's not that bad because we analyzed them before and we cut the content that's unused in the given layer. The tiled materials. Most of them are 256 pixels. Some are 512 if they need to be. Fabrics can be super small. They are between 64 and 128.
And the third one was
the order of layering. So the order is, of course, set in stone. It's like you saw there. You can swap the materials, but it's in editor. And then we optimize the rendering by going like top down from top layers. So if layer occludes layers below, they get cut out. They are not drawn. So this is much more efficient than default layer blending that you have in game engines.
But it's easy to forget about it. Like, you know, you can simply add too many textures, too many layers, and you forget about it, it looks good. So we also have a solution for it. In Substance, we have a separate shader, which is preview mode, and it will show you what the finished performance of each part of the mesh will look like. And of course, we don't render the layers which are occluded completely by other layers, or to be more precise, the pixels that are occluded. So the shader knows about it, and there is no false positives. Oh, here's one question.
There is a mic and there is a question.
So what about LODs and hierarchical LODs?
Okay, so the question is, what about LODs and hierarchical LODs? LODs meaning simplified versions of the mesh or the material with distance. And hierarchical LODs were called proxies in Red Engine. They are actually simplified variants of, let's say, entire block or entire district just baked in for performance for high distance, far distance vista. So the thing is, this system works for close-up. You can make it work for further objects. So LODs still used multi-layer. It still works very fine. Especially the smaller the object, the less pixel cost you have in rendering. So you don't have to rebake it for LODs. However, when we are dealing with proxies, meaning baking the entire building into a single material, we can't still use it, because then we would have to combine all the layers of all objects, and they have different materials applied. So for proxies, for HLODs, we have to bake it down to a simple physically based rendering, basically flat texture.
And I have a question about batching and how this all the big material will batch with the different objects when we have this up to 20 layers. And for example, 2 instances uses a different number of layers, so the texture inputs are different, and the data we are sending in is different. So those materials will can batch in your tech, or how do you approach this?
Okay, so the question is about batching. This is something specific to basically how CPU has to tell GPU what to render, and typically we have a problem if there are too many separate meshes or too many separate materials, because each time the GPU has to be stopped, then the CPU says, change my material, assign different textures, and then draw these triangles. So the more unique materials you have, more unique meshes you have, it's a problem. So this is what is referred to. So here, we didn't do anything special for the batching. We only did sorting. So you can sort your draw calls when everything almost is this multi-layer thing in a single shader, then you can at least sort that draw multi-layers first, right? This helps with more stuff, because if we know that multi-layer supports only solid drawing mode, not switches between, you know, opaque, transparent, something, it has a very specific set of, let's say, features, then you can, for example, with big confidence, just draw multi-layer first and know that it can occlude other objects. So in that regard, we didn't do something specific for batching, but it helped in many areas by allowing us to order stuff, to draw them with confidence in one go without worrying for transparency. And finally, by having like this collection of textures where in so-called bindless mode in DirectX 12, meaning that every layer can refer to a texture in memory very quickly. So we don't need to reattach them as you typically have in material instance. So imagine a huge atlas of textures for the entire game.
Don't be shy. Any more questions?
We have like 7 minutes, so feel free.
Oh, there's one.
Hello. So you said you are having like 20 layers of those materials. Are you painting like different colors that have like custom hex code, or are you having 20 UV sets for that asset?
So the question is, when we have these 20 layers, are they all different UV sets? So no. There is one UV set that you make manually, and the only thing that changes per layer is programmatic tiling and offset. So this is all, or let's say on UV 0, and then you just tile the material by multiplying the UV, and you add to the UV, shifting it. So that's a little cost, but it's not as bad as storing multiple UV sets. The main important problem about having just one UV set for everything is that the tangents and normals depend on UVs. So you shouldn't rotate your islands. They should always face up.
Thank you.
Hi guys, thanks for your talk. I just wonder, do you have a different mask for the levels of the transparency? So let's say you have like a dirty glass or just stain a window, and how do you decide about the levels of the transparency?
So the question was, what do we do with windows and with stains on them? So basically, many windows that are not, let's say, crucial for the low level of the city were just shiny material, so solid. But when it comes to transparency, we use a special material. You may kind of remember the one with parallax.
Oh, we actually have quite a lot of those. Like vehicle glass, typical window glass, some special window glass with tinting, and some other variations. There's a lot of them.
Yeah, so then we went away from multi-layer. And for Windows, we had, for example, a fake parallax that shows you interior, but there's no actual interior. It's just drawn in the shader. So then we just did, multi-layer for the wall, but the polygon of the window was cut out and replaced with other material.
The tricky part was that if you have proxy or hierarchical LOD of such building, you also want to have support for that parallax material. So we have our custom baking algorithm in Houdini, and it separates those meshes with this material, and they are simplified, but they have a different material, so they still have this effect.
Yeah, so you still have, for example, glowing windows or windows with different color in the far vista, because they are like cut out by the baker, and HLOD flattens the building, but not the windows. So there are some special cases, and these cases shouldn't be tried to be solved with multi-layer. We just have to pay the cost that many materials will be separate.
Hi, thanks for the talk. So I have a question about masks. Do you use black and white images, or do you use channels like RGB for separate mask, which is more performant?
Okay, so the question is, do we use separate files, grayscale files for each mask, or do we pack them into channels of RGBA? Because that's a very neat trick that typically in game engines you should try to use, is that if you think you have 4 grayscale textures, you can actually put them in the red, green, blue, and alpha channel of a single texture. It already cuts the amount of files and texture fetches by 4. So typically it's a great technique, but here we didn't use it. We went even further. We written a custom compression that basically splits the image into little tiles and analyzes which them are needed and which are not used, and then repacks them into one big grayscale atlas. But that's just inside the engine. The artist sees separate 20 files, PNG.
You can actually export PNG, so if you want to test it in any other software, you can kind of hack your way and port it.
Oh, that's also a cool thing. The surprising benefit of doing it in Substance was that Substance can export the content of its 2D viewport. So we can export the flattened version of this complicated system to a standard texture to use for marketing in Arnold and V-Ray.
That's how we did it, this blurry preview in Blender with lower resolution, because we had only 4K texture, and there was a little detail, especially on those straps, because Fabric needs tiling, but if you have some detail like dirt, it's no longer tiled. And yep, didn't look good. I think we're hitting our deadline, but maybe one last question. Oh, we have 5 minutes. Thank you.
So again, about blending and those 20 layers that you blend together. And you use those microblend textures to blend them together. And did you have a separate microblend texture for every layer? So the artist can choose for every layer how it's blended with another layers?
I will put it in a bit different words. There is material per layer, and materials are crafted by someone else who decided if they can use microblend or not. And if they can use, you can use any microblend you want on any layer, supposing it has been allowed. So yes, you can have 20 microblends on single mesh.
Okay, so maybe one more question. If you have up to 20 layers, really, then you can really use a lot of materials that each of them can use separate textures, which can lead to many texture lookups in the single material. So how do you approach that?
Yeah, so the question is, if we have so many layers and each of them has at least 5 textures, right? Albedo, roughness, normal, microblend. Then how do we manage this if this is already like 150 texture samples per draw? So the first thing is, in typical game engines, you won't be able to do that because of the exact reason you said. There's too many textures assigned to a single shader. So you need some technology for atlasing and for just referring by UVs, shifting UVs or shifting texture index. So that's one thing. Second thing, we measured what is the average amount of layers per pixel in all characters. And it turned out to be below 3. So typically, each single pixel blends just 3 materials, because usually you have some jeans, then there is some, for example, red rose embroidered somewhere on the arm, but this part of jeans doesn't have it, right? So it's only there. So if you make your layers sharp enough, and we help artists by showing a preview mode of performance cost, then they can paint in a way that usually a layer occludes somewhere below, and then you can just cut it out. So yeah, it's 20 layers, but actually you shouldn't blend more than 4 per pixel. Okay, so I hope you enjoyed the talk, and thanks so much.
Yep, see you later.